everyone. Marc Gratacos, I'm the managing partner at TradeHeader. I'd like to thank Algorithmica and also FINOS for organizing this event. I'm going to talk about CDM. So there are people in this room that know more CDM than I do, but still they asked me to present on CDM. So one thing I wanted to say is that we are working on a free FINOS CDM introductory course. And actually, we are compiling materials. My colleague Gina is helping with this. We're compiling materials that we have to be able to produce a course that we'll offer through the Linux training platform, which will be an introductory course that will be free. And as part of the process of compiling materials, we put together some slides for today's presentation. The idea that we wanted to give to you is what is CDM, how it relates to things like FPML or ISO 2022, what are the differences there, but also to kind of show you the potential of using CDM in multiple projects, like the ones that are presented today, but also others that you may be familiar with and that you wanted to use in the open source space. So what is CDM? CDM, as Mau said before, is part of the FINOS Foundation. It's a project of the FINOS Foundation, and it's the whole idea about CDM. It's a machine, standardized, machine readable, machine executable set of libraries to be able to standardize products, so financial products, but also, and very importantly, business events, okay, related to those products. So that's how the whole CDM started. The reason is because, as you probably know, in financial institutions, products and the representation of business events is completely inconsistent, right? Every firm has a different representation of products and events, and it's very difficult to automate, but also to exchange information around these products and around the life cycle of the product. So the full scope of CDM is to be able to standardize both products and events. So if we do that, we'll be able to reconcile information between firms, but also we'll be able to do other things combined with AI or other technologies that will help streamline some of these processes. So the whole idea is once we have standardized that, we can do other things as well. There is some documentation available in the FINOS Foundation. CDM is fully open source, and it's maintained by a set of firms that are contributing, like us, like TradeHeader, but also you have other financial institutions involved in the project. And we'll go in more detail about how we manage that. Moving on, yeah. It's a very important point, and if I am able to explain this, I think I'll be accomplishing the goal of today's session. CDM is not only a data model for products and events, but it's a functional model. What it means is that it has the potential of, it's already there, but you can define functions on top of the data, right? And that's very important. We'll see some examples today. You're able to express things like validation rules, validation constraints, and also transformation of the data. So it's not only the pure static data object of an asset-backed security or a derivative, but also the functions on top of that. And that's very important. Okay, so that's the difference between CDM and other financial standards out there, like FPML or ISO. Those standards are purely a data object, like they have a data format, but they don't have any functional aspect on those standards. And CDM has. So it has this extra layer where you can express transformation of the data, validation of the data, and that's something that's very important and very powerful at the same time. Okay, like other standards, they don't have that. And we'll see some examples today, but think about like the potential applications of these functions in things like regulatory reporting, like calculations of risk, for example. There is a huge potential of applications on top of the pure representation of products and events that you can open up by using CDM and the functional capacity of CDM. Okay. Moving on. CDM is a core of other applications as well. One of them, and some of them are not fully open source, like digital regulatory reporting. This is an extension of CDM to cover regulatory reporting that it's developed by ISDA, International Swaps and Derivatives Association. It's a free-to-use project, but it's not open source yet. We'll see if it becomes open source at some point. But right now it's not open source, but it sits on top of CDM. It's using CDM to be able to do regulatory reporting for the derivative products. And another aspect, which is part of the CDM open source libraries, is collateral management. So there is an active FINOS collateral management working group that provides input and develops the content for collateral management. And that's why it's starting to get traction for some of the vendors on the collateral management space that are using CDM to standardize their interfaces to be able to use the collateral management solutions out there. So there is this one is open source, it's part of FINOS. DRR is still not open source. It's free to use and it's developed by ISDA. We're heavily involved in DRR. We have some knowledge of the collateral management space as well. But these are quite active activities that sit using CDM. Okay, so if you're interested, just click on these links or let us know because we're happy to have these ones. But there are others. Okay, so there is some activity working on initial margin. There are people using the CDM for standardization of business events as well, or structured products. So there are many activities going on CDM as we speak. The classic questions that we get and some misunderstandings around CDM. CDM is not a system. So what we deliver is a set of executable code, but it's not a platform. So you still need to use that code in your implementation or your solution. CDM is not an actual application, and it's not a regulatory engine. So related to the DRR project, we sometimes have the misunderstanding that CDM provides a regulatory engine. It's not. It's a set of libraries that you can use in a regulatory engine, but you still need to implement that yourself. Okay, so it's a component. It's an executable code that you can use, but it's not an app. It's not a system that you are able to call, for example, from an API. CDM is it's an open source library, as I said, of data models and functions, executable in Java, Python, and other programming languages that are available. The most complete versions of the CDM are the Java, which is the default one, and Python is catching up. The others are not at the same level of completeness like the others. Okay, so there you'll see that there is libraries available on Scala, C# as well, and others. But the most complete one is the Java one, and we are working on the Python library, and we are catching up on Python, but we're still not 100%. So if you need to implement CDM right now, I would recommend you to use the Java distribution. Okay? As I said before, it covers derivative products. It covers securities lending, repos, and standard products such as securities and ETDs, exchange rate derivatives. So the wide range of products it's expanding. We have a working group working on structured products as well, and we're working today on structured finance. So it's rapidly expanding the coverage. It covers the full life cycle of transactions, and that's very important. It's not only the product representation, but also the whole life cycle of these products that we're covering in CDM. So you'll see things like post-trade events for derivatives covered. We're working on also things like collateral management, as I said. So there is a whole set of processes that are fully covered. When we mean processes, it's not only the data representation of those processes, but also the transformation that happens from one state to the other of those processes. And that's very important. Okay? And it's a library of code, so you can use that in multiple use cases. We have firms, banks using CDM already in production for regulatory reporting. We have others on collateral management, others for standardizing the life cycle of trading. So there is a wide range of applications in production already using CDM. and it's mainly used by banks, asset managers, but also fintech companies like ours, using CDM in their implementations. Okay, open source, free to use, wide range of products and events. Why not? Right, using. So, I'm going to go into a bit of more detail now in terms of what are the design principles and what are the different components of the CDM. So, going to a bit detail. Some of the principles is normalization. So we're trying to have like layers of abstraction of the models. And the idea is that we have a set of common components, and from those components we extend to create other components. Examples are, we have a payout base that has a structure that is common to all the payout structures of the different products. And we have an option payout that extends that payout base. So there is extension of types, and there is also the structure of having different common components that share content. Okay? Yeah, so moving on. Composability. Products, I will talk about that. Products are composed of different payouts, okay? And those payouts are reused across multiple products. Okay, so things are composed with the whole idea of reusing the representations for different use cases. We'll talk about that when we talk about product models, product classification, but you can get the idea. Instead of creating a specific component for an equity swap, we're going to use the interest component of that representation for the different derivative products that we have in CDM. We're not going to create specific interest components for each one of them. We're going to use the same one across the different products. So composability is critical in the CDM. And we have business events as well that are composed of other events. And we're not going to go into a lot of detail, but think about the same idea. If I have an event that applies a specific change to the trade, if that change is also present in other events, I will use the same definition. I'm going to recreate the same thing twice, right? So it's critical. Moving on. Yeah, and this is a critical point, and it's around data mapping. Okay. Why is that? As you know, in the financial industry, we have lots of different formats that are being used. Vendors use their formats. Banks have their legacy formats as well in their systems. So data conversion is a critical point. And when we're using CDM, we always get the question, how can I convert my internal format that I'm using, converting that to CDM? How can I do that? And there are different options there. There are open source tools out there like Legend, for example, which is part of the FINOS umbrella, which allows us to do mapping between FPML to CDM, for example. There are commercial solutions, for example, Rhinosis, and we're going to use some of the tooling from Rhinosis, a tool called Rosetta, which is a commercial tool, has a community version that we'll show you, but it's a commercial tool that provides some mappings from FPML to CDM as well, or you can have your own custom implementation. The whole idea is to be able to build a CDM object that has all the data that you need to represent the trades and the business events. Once you have that, we're able to apply all the functional logic, we're able to report on that. So the whole idea is, how do I build this CDM object from the data formats that I have? And those are the different options that we have available. It's not easy in a sense that it's not a plug and play, but there are multiple options that we can use to do that conversion and build the proper CDM object to be able to apply the different use cases. Okay. Yeah, that's an important point on this is that how do we apply this functional aspect to the CDM? And the thing is, we can apply extensions, but also we can apply conditions within the type definitions. Conditions are rules that we want to apply to a specific type. For example, I want to apply that an event date exists. I want to control that within the type definition, and we can use CDM to do that. So it's not only the data representation of a business event here, we are also forcing that this representation of the data that a particular field exists. Okay? We can do that by applying functions. In this case, what we call conditions. That is a specific set of functions that control the behavior of a specific type. Okay? So let's imagine a structured product, and we want to apply some validation within the product itself. We can define conditions inside the structured product definition. Okay? And this is quite powerful because at the end what we're generating is a function in Java or Python or others that control this data. Okay? So we can create a data validation tool available as part of the CDM.
Marc, sorry, quick
yes.
question. So the event date, for example, is one of, if I understood correctly, is one of the features of business event, right? And I guess in business event there are different conditions, and the list is is dynamic, or it's basically, it requires, if I want to add a new condition, how do I do that?
Yeah, you will need to add, you can add conditions at the domain specific. So this is the DSL format, the syntax. So you can add a set of conditions within the type, and those conditions will be generated to basically code as validation functions. Okay. So you would apply, so this is the kind of the DSL, like the logic syntax. You can apply them, and they will generate it into validation functions. And the validation functions then you can apply it to them, will be applied to that to the particular type of model.
Okay. So for example,
Yeah, go ahead.
Okay, I guess Maurizio will.
Okay. Right. So how does it work? So we have a set of models that are expressed in DSL. Now it used to be called Rosetta DSL. It's now called Rune. This is the syntax of the model, and then from that model we have code generators that generate the code into Java, Python, and so on. Yeah, and as I said before, the Java distribution is the most complete, but we have now Python and others also available. Okay. Moving on. Yes, these are the code generators. I put out the link here, and these are the ones that are available. There is also an open question now in who is supporting what, so we're trying to filter what the firms are contributing. We are contributing on the Python one. And the Java one is the one that is being generated by default. And there is a code generator repository for firms that want to contribute on these code generators. So yeah, if you want to participate, we'll welcome some help on this. Okay. Right, moving to structure. Any more questions before we move on?
The question of the Python code is hosted in the Rune repository. The Python code generator.
Yes, it is.
It's part of the release generators in the FINOS repository.
All right, okay, cool. So maybe later on we can share the URL so if anyone is interested.
Yeah.
Thank you.
Okay. The main CDM, the first thing you'll see in the CDM is the type definition. So it is very similar to a type structure if you guys are familiar with type structures. So it's very similar. Rule as a DSL syntax defines the name of the attribute at the time, and then the cardinality. So as you guys are techies, you understand this. It's not basically very different to other definitions. So we have a set of basic types on the domain specific language in the DSL. So there is nothing special. The only thing is we have also a set of comments, human readable comments for each one of the attributes, and those become very important when we apply this to things like reporting or specific use cases. Okay. But yeah, this is quite basic. Moving on. Yeah. There is a set of lists which are kind of enumerations, and those are list of values. Okay. spend a day on this because there are internal and external list of values, and we're trying to see how we can externalize some of those. But just for today's understanding, you'll see a set of enums in the DSL, and those are static lists. The actual enum can contain only 3 values: new, correct, and cancel. That's it. Okay. If you add an extra value, the library will complain. Okay. So it's strongly validated, but also there are some charges in terms of extensions. But yeah, enums, if you see enums in CDM, are a list of values and have a static list of values. Okay. Moving on. Yeah. So just to show you how you can navigate CDM using the community version of Rosetta. This is a free version of the tooling. It's basically a tree structure. Okay. So showing you can navigate the entire CDM, which is quite large, using basically the graphical view. And it's basically to be able to show you the entire tree structure on the CDM. Yeah. Just uploaded the demo on YouTube.
That's audio?
No, no audio. Yeah. So this is the version of CDM using Rosetta. It's, as I said, there is a community version, it's absolutely free. And you can navigate the entire repository of CDM. And I'm showing here some of the types. And you can go to the graphical view, which is here on the top. And you can see that we have the type structure, in this case a workflow step, which is the kind of the initiation of a trade activity. And you can see that workflow step has some documentation. In this case, it's defining what workflow step is, and then the set of attributes inside workflow step with the kind of cardinality of each of them, right? So account is 0, can be repeated multiple times. Action enum, action is optional, so 0, 1, and so on. I have the list of attributes that you see here with the tree structure, but with the cardinality here on the right side. And I can expand from that. So the graphical view allows me to expand and see the content of each one of the attributes. So in action, we have a enumeration, right, with 3 values, the new, correct, and cancel that we saw before. And we can navigate the entire model with this graphical view. Each one of them we can browse, we can see the annotation, so the actual documentation of each one of the values. And we can navigate through that. Since CDM is very big, it's becoming very large, it's quite handy to be able to navigate through the graphical view and then click and see the actual text. So we can navigate from graphical to the textual view that we just saw. We can expand on the object model. We can expand, for example, on party, and we have the party model to define the entities that are part of the transaction. And again, we can navigate from graphical to textual and then see, for example, what are the textual view of the type party with the different components of that. Going back to graphical, we can expand on the tree and, for example, see the reject, which is just a Boolean type, so it's just a Boolean attribute. So it's a true false, and keep going. So we can expand on the type model. Okay, so this is quite handy because, as I said, like it's becoming a big model. So to be able to navigate and change from one to the other, it's quite useful. Okay.
Back to the slide?
Yeah.
Okay.
Okay. Yeah, I'm gonna pause with this one. If you can move on. Yeah. One of the most important parts of the CDM is functions, as I said before. And functions in the DSL syntax are defined as this. So we have a fun, and then we have a set of inputs that are the input parameters of the function. We have a set of outputs. So in this case, inputs are a set of transfers, and outputs are also a set of transfers. and then the actual logic of the function. In this case, I'm getting the transfer that have a currency, okay, with this syntax. So I'm filtering all the transfers of the input, and I'm just getting the ones that have a currency, which means they are cash transfers. Okay, so this is very important because you'll see many functions defined in the CDM to be able to filter the data, but also to transform the data. Okay, and this is kind of the syntax that we're using to define functions. Okay, so the output in this case is the functions that have a currency, which means they're cash transfers, and the idea is to filter them by checking that they have a currency. Okay, we can have functions that call a lot of other functions. So there is composability of functions as well. Okay, so you don't have to really find them as, every time, but you can call them across the board. Moving on. Yeah, namespaces, and this is important. So the CDM is organized in different namespaces, so in different packages. The point I want to make here is that it's a way to group things together, but also it's a way to extend the CDM if you want to. So you can create your own namespace and generate and extend from the existing CDM namespaces. Okay, so namespaces to be able to group things together, but also to extend on top of the CDM. So there are certain use cases that are not yet covered by CDM. You say, have a solution for regulatory reporting for structured finance. I can create my own namespace and import the CDM ones. Okay, so very important, not only for grouping things together within the CDM, but also for extensibility. Okay, this is important.
So for example, if I have a CLO and I want to model this CLO in CDM, I can use a namespace.
Exactly. You can create your own algorithmic CLO namespace and extend it from the existing CDM namespaces.
And this is something that's and Luca can release a namespace using the Java means artifacts or Java artifacts. I can consume these artifacts and build on top of it and redistribute.
Yeah, that's cool. Potentially, yes, or contribute back to the CDM and generate from the
right. But again, it's like I see that it's interesting that you can define ownership on your own code, right? So you can divide like this is what Luca did, and that's his own.
Exactly, a commercial. Yeah, absolutely. That's a whole idea. Cool. This will be algorithmic namespace importing the CDM base or whatever namespaces it needs to perform the CLO representation, for example. As if it was importing a Java library. We will import from the DSL model and go to the code generation and generate the resulting classes from new extensions. Okay. Cool. Yeah, product models. Since we are talking about structured finance, I thought it was interesting to look at products. Okay, and some of the teams here have been working on structured finance products, but in CDM there are some interesting features around products. The representation of derivatives is using this tradable product, okay, and then going into the product model. It's not a surprise. Derivatives are represented using contractual product, okay, which is the idea of having an OTC product with the reference to the actual documentation. But as you can see, there are other products like securities, loans, indices, commodities, baskets, asset pools. So there are a set of kind of underlying products also defined as part of the CDM product. Okay, moving on. All right, talking about the actual product representation, the securities, but also contractual product, use these economic terms. And economic terms have the full set of attributes that you need to represent a full OTC product. Okay, and this is kind of weird inside securities, but the reason is because the security model is used also to represent ETDs, exchange traded derivatives, in which in some cases for reporting, you need the full economics of the product. And economic terms have that. So within the CDM, economic terms have all the full details of the payout structure of the product to fully represent OTC. Okay, OTC or also exchange traded derivatives. Right? Moving on to the next one. Right. And this is probably the most interesting part on products is the composability of payouts, as I mentioned before. So derivatives are represented with a set of payouts. Okay? And as you can see, a payout model have different set of payouts, like commodity payout, forward payout, interest rate payout, and so on. It's a list of payouts. And the question is, okay, but how do I define the product if I have a list of payouts? So going back to the point about functions, we have a set of functions that, based on the use of these payouts, will give you what type of product it is. And it's what we call qualifying functions. So in CDM, we have a set of functions that their job is to simply see the payout structure that you have in your product and determine what type of product it is. Okay. So those qualifying functions will tell you, oh, this is an interest rate swap. Oh, this is a credit default swap on an asset-backed security. So those functions will take care of the actual product representation. Okay. And this is very powerful because, as part of the CDM, what you're getting is a set of functions that at the end are a product classifier. Okay, so we have within the CDM a product classification because the functions that classify products can be seen as simply a tool that is able to classify products for you using the CDM. Okay, so this is quite powerful because, as you can imagine, once you have product classification, you can do reporting, you can do margin calculations based on the risk of the product, and so on and so on. And the whole point about this is standardizing the representation, the classification of these products. Yeah, I'm going to skip on this one. Yeah, talking about qualifying functions. Yeah, I'm going to skip on this. The whole idea about qualifying functions is that, based on the representation of the product and based on the structure of the payouts, I'm going to give you what type of product it is. For example, here, when I classify a product as a FRA, forward rate agreement, I'm going to check on economic terms, which has the product details. And inside the economic terms, I'm going to look at the payout. And if it has 2 interest rate payouts, and it has 2 payment dates, and if there is no inflation rate, so will be, and it's an interest rate payout, will be classified as a FRA. So I have a set of functions there that will classify the product. Again, I'll just give you an example with just to show the demo. And as I said before, the power of the CDM is that once I get a trade in a CDM format, I'm able to, using these functions, I'm able to classify it. And this is quite powerful in a sense that I'll be able to use that in multiple scenarios. Just show you a demo of this. So I'm gonna use an example of a classification function, which is the interest rate swap fixed float, and I can see that I'm inputting as a function. The input is a set of economic terms, so a trade, and I map this to the taxonomy. This is a product classification developed by ISDA. It's just a label. So once I get this function applied, and this function is true, I'm going to assign a label, which is the type of product. In this case, it's a taxonomy value. It's a label from ISDA that tells me that this is an interest rate swap fixed float. And this is the actual logic. I can test this function by simply looking at this qualifier. I can look at the function and apply a transaction to see whether the transaction I'm sending to that function is a fixed float interest rate swap or not. So I'm just sending a trade in JSON format, in CDM JSON.
All right. CDM broke the internet. She executed the function.
It was a bug in the function. Yeah, so we're applying we're sending a trade in JSON format, and you can see that in this case it's a true, so it means that it's a fixed float swap. I can send another transaction and basically test this to see whether it's a fixed float. In this case, I'm sending a lazy swap, which is a float swap, and I'm gonna get values. They are false, so I can check the function. I can see it's not a fixed point. So as I said before, this is a very simple scenario, but you can use this to basically build a product classification tool using these functions to tell me what type of product it is. It is a swap, it's not, or apply labels on top of that as well. Okay. Moving on to the slides.
One question, Mark.
Yeah, sure.
Is a function can output data, so can enrich data, but it cannot belong. So on one end, we have the constraints that are actually validation. The function adds stuff.
Yeah.
Can it delete?
Can it delete? Yeah, it could delete if you want to.
Modify as well?
Yeah.
So, but anyway, but it's like an additional step on the paper.
Yeah.
There is no other use case for functions, like integration, for example, or.
Well, yeah, there is. Yeah, sorry. Yeah. There is a use of function which is enrichment. Enrichment could be applicable to external sources of information. Okay, and the function will tell you what is expected in terms of inputs and outputs, and then it's during the implementation, it's basically on your hands to do that call to the API to do that.
Right. Okay.
But the function is defined. Okay. Right. So there is an expectation on the data that it's received from the external source of data. Okay. And that's very critical, especially on things like reg reporting, right, when you need to enrich the data to get things like LEI or UPIs or so on, that you don't have in the CDM itself, but you are expected to call an external service to get the data. And in CDM, you have the ability to define that as a function as well. Perfect. Thank you. Sure. Yeah. Moving on, I'm gonna finish this. There is the CDM Java distribution. There is some information here about how to install the Java, how to use it. If you need some help on that, just let us know. It's on the slides. And finally, just to basically encourage you to participate in the project. It's run similarly to other FINOS projects. We are maintainers now of the project, and we are looking for help on this. It's basically similar to other contribution processes that you may familiar with other open source projects, but we have a set of issues, features, bugs, any new projects that you want to contribute are raised as issues in GitHub, the FINOS GitHub, and then we manage that. We want to basically associate issues to contributions. We manage those contributions as part of the working group activity, and then we approve them. Those contributions are basically pull requests, and once they're approved, they're part of the project, and so on and so on. So it's not very difficult. It's very different from other management of source code. And the whole idea is to basically build a community that participates in the project and expands the coverage to include other features that are not part of the project right now. Okay, so we kind of encourage you to participate and to expand on the models. It's growing. We have much more products now. We have new projects in the pipeline, so it's quite extensive. But we're looking for new faces to help us on the project. Okay. I think that's what I have. Yeah, well, just skipping this one. On to the next one. Yeah. As I said, set of GitHub issues as part of the model. You can see all the open ones in GitHub on FINOS and some of the discussions that are taking. We label them and then we triage them and we assess them as part of the working activities. Finally, I'm going to skip this one. Yeah, we have a set of working groups as part of the FINOS CDM working groups. The Predictive Products in Business Event working groups, these are covering all the product contributions. So if we had issues around how to represent structured finance, we'll go to this working group. We have a specific working group in FINOS for collateral, for CDM collateral. This is all CDM. So we have another for CDM structured products, and we have a CDM technology architecture working group that takes care of things around technology, like the serialization, the DSL syntax, and so on. And finally, all the PRs, so all the pull requests and contributions are reviewed and approved by the CDM contribution. Okay. So this is completely open to anyone that wants to participate. You don't have to be a FINOS member to become part of the working groups, but depending on what you want to do, there you need to basically join one of these working groups. Okay. And that's it. Any questions? Again, we are working on a training for FINOS on this that will be available through the Linux platform. And if you're interested as well in participating and contributing, just let us know. We're working with FINOS on that. And stick around, so if you guys have any questions afterwards, just let us know.
Mark, a quick question. I know there are some teams working on legal tech track, so they have a CLO prospectus and they want to codify the prospectus into CDM. So the question is, do you have an idea or suggestions on how to from where to start from?
Yeah.
Right? So what's the
Yes.
low-hanging fruit?
Yes, I didn't have time to cover all the aspects of the CDM, but as you can imagine, as part of the representation for the derivatives, there are references to legal documentation, okay, which are the kind of the starting points to be able to reference the legal contracts that govern some of these transactions. Those documentation references, which are basically how we reference the legal documentation, it's not a full legal document representation, but I think it's a starting point to be able to develop a legal document model for things like structured finance. Because at the end of the day, it's the linkage between the actual transaction and the actual legal documentation that govern those transactions. So I think the starting point is that documentation block that is part of the contractual product, which are basically the legal contracts that govern these transactions. Because there you have references to master agreements, master confirmations that govern the trades, CSAs, and so on and so on.
And did you cover this in the presentation?
No, I didn't. Sorry, but planning issue. But as part of the contractual product that they covered, if we navigate that contractual product, it was
I think right.
Here.
Yeah.
Inside contractual product, if you go with the next slide. Yeah, here as part of the economic terms, inside the economic terms, we'll see basically inside contractual product, click here, there is economic terms. Inside the economic terms, there is a reference to documentation. In documentation, you have these references to the legal contracts. That will be the starting point.
Okay.
So it's here inside the economic terms.
Okay.
And there is and this is something we have been discussing, because some people coming from the legal tech are starting to see how we can standardize some of these legal documents that they have in spreadsheets all over the place in the banks. And I think that's something that will get more attention in the upcoming months, because there is a full disconnect between the two.
It's a trade.
Trade, it's a trade?
Yeah, not in the economic terms.
Okay, sorry.
Higher level.
At the higher level, sorry. I missed.
If you go back,
Here, sorry.
in the contract details.
Here, trade,
Contract details.
Yeah, sorry. Contract details. This will be the starting point, sorry. Because this joins the actual economic terms and the actual legal documentation. So this will be the starting point. But as I said, there is only a discussion because I think there is an interest to covering the CDM or the legal documentation part, because there are no data models, full data models for things like master agreements, confirmations, and so on, that will help you make the link between the actual transaction and validating that transaction against what type of collateral you are required to host in terms of quality, or what are the prospectus. Is it consistent, the trade that you're sending against a prospectus of the product that you announced? Things like that. That requiring a cross-checking between the legal data and the transactional data.
And I understand that this is actually already done by ISDA and other trade associations as namespaces on top of the CDM.
There are some, but I don't think they are fully represented models for some of these legal contracts.
Right.
there are like some placeholders, but I don't think it's fully expressed, because in some of these legal contracts there is a lot of optionality, but also a lot of conditionality between the fields. And I don't think they're fully expressed right now in the industry. Most of them are commercial implementations of these contracts, or sit out there in spreadsheets where there is a team of people in the bank that has a spreadsheet that checks whether the trades that they're sending are consistent against the collateral they're supposed to send, basically.
But technically speaking, let's say that the extension pattern that CDM provides us is all we need to actually build on top of this, right?
Yeah.
Okay.
And develop. It's more getting the data as usual, like getting the and basically creating the model.
It will also allow you to model different state transitions, not only for trade or post-trade, etc., but also for the pre-trade events, all related to legal agreements.
I think what's happening right now in the industry is that banks are spending a lot of money on having controls of the transactions, but they're manual controls.
Yeah. So they invest and they don't want to.
Yeah, exactly. And some of this logic is using spreadsheets out there. The transactional data may be automated, but the actual legal data, I think there's still lots of spreadsheets out there that are managing that. It's hard to believe, but it's
for the triggers, you mean?
For the triggers, yeah. For checking whether you're sending a trade, the underlying is a bond. Is that bond qualifies against my CSA? Yes or no? That qualification, that checking, I think it's still manual or using spreadsheets that people are checking. So it's a bit scary, but that's the problem. And there is no, I think people are looking for some sort of data model of that legal contract so you can connect the two parts. The trades against the legal contract that governs that transaction.
Yeah.
And I think probably in structured finance it's the same case or even close.
Yeah. And just to close the loop, so once I have modeled the CLO using contract details and economic terms, then if I know that I have to report X and Y to the trade repository, then I can basically set up a DRR that does the reporting.
Yeah, we will use a qualifying function to say what type of product it is. It's a CLO. Oh, okay, I need to report that field and this field.
So it's a qualifying function.
Yeah, we'll use the qualifying function that are part of CDM. To basically say what type of product it is. We'll call the function, say, oh, it's a CLO. Okay, then I need to report these fields. So we'll use the qualifying functions to filter what type of product it is and then to report based on the product.
Well, thank you.
Thank you.